All right. Good morning, everyone, and welcome to the Aquarium of the Pacific's Online Academy. My name is Dana. I'm a member of the Education Department here at the Aquarium of the Pacific, and today we are coming to you live from Long Beach, California, where we're going to be exploring our Earth. That's right, the entire Earth. Now, there's some pretty cool ways that we're going to do this as a team. My name is Dana. Like I said, you'll see me in front of the camera, and my friend Carrie is going to be controlling all of the magic back here. Now, that's the team within the studio, but we are all working as a team today because not only is it just Carrie in here, but we actually have a text line set up where you, watching live, can reach out and say hello. So you'll see this phone number right down here. It's 562-286-1838. You're welcome to text that phone number, texting only, no calls, and share in your thoughts, your observations, any questions that you might have throughout this entire program. Now, if you find yourself watching after our live stream, which is Wednesday, August 17th at 10 a.m., go ahead and instead of texting, shoot us an email at live@lbaop.org. It's Long Beach Aquarium of Pacific, lbaop.org. And we can go ahead and get back to you whenever you send those questions in. So we're excited to have you all join us, excited to have you explore planet Earth with us, discover a little bit more about what makes our planet special. So let's go ahead and get started. I'm going to step off the screen and just give you a moment. What do you see going on the screen here? What's happening? Yeah, this is our coral reef shark lagoon. You'll see there's lots of sharks swimming around, lots of little fish, and lots of colors. Now, if you've been tuning into our Aquarium Online Academy for quite a while, you will recognize this space. This is our Shark Lagoon exhibit here at the Aquarium of the Pacific. But more importantly, you'll recognize the habitat, right? We spend a lot of time talking about coral reefs. We spend a lot of time talking about kelp forests, a more local habitat that we have here in California. And today we're going to be talking about coral reefs and kelp forests, but we're going to do so zoom out. So my friend Carrie's going to go ahead and open up the door into a new application that we're going to be using. And this is something that you can actually download on any device that you have at home. It's called the SOS Explorer app. Science on a Sphere Explorer app. SOS, okay? It'll actually be down on the bottom of the screen when it comes up here in just a moment. You'll see it. Oh, it's kind of right underneath here. It's NOAA's SOS Explorer. Now, NOAA, what is NOAA? Raise your hand. Have you heard of NOAA before? No, not the name NOAA, not the person NOAA that you might know, but instead NOAA, NOAA. Okay, now those are letters that stand for the National Oceanic and Atmospheric Administration. And basically, when you look at the weather or you look up anything about the movement of the Earth or anything like that, you're learning from NOAA. And this is an app that they have that allows you to explore. So what are we looking at right here? What is going on? What is all this? If you said planet Earth, you are right. But I want to know, how did you know it was planet Earth? What on this screen told you, other than myself, that we were looking at planet Earth? What do you think? Anything look familiar here? So maybe these shapes are familiar? Maybe even the colors are familiar, right? So we recognize that. That's Africa. Now, if we're looking at all of the blue coming on the screen right here, that's going to be the Atlantic Ocean right over here. And now we're starting to get something maybe even a little more familiar for those of us who live in the United States. I know we do sometimes have viewers from all over the world, but that is the United States. And I am coming right here. I live right here in Southern California. But I want you to observe what happens when we rotate all around the Earth. Whoa! What's going on there? I can almost get it so that we barely see land. That, my friends, is the Pacific Ocean. And that's what the Aquarium of the Pacific loves to talk about. So the Pacific Ocean is one of the largest oceans, or is the largest ocean in the world. You can see it covers almost half of our globe. Now, our planet is made up of about 70% ocean, right? And so as we look around and explore this map, you'll start to see those blue shapes that tell us it's water and the brown and green shapes that tell us it's land. But what happens when I look at the top? This is the very top of the globe. What is that? Why would we be seeing white? Yeah, my friends, if you said it was snow or ice, you are right. This is the North Pole. This is the Arctic. And there's snow and ice coverage. Now, if we go all the way down to the South Pole, that is Antarctica. And so you can see it is the same. It is covered in snow. It is covered in ice. So these are all clues that as we look at our planet, we start to see patterns, right? But is anything missing from this view here? Let me zoom you in just a little bit. Is anything missing? If we were to go up into space and look back down at planet Earth right now, is this what we would see? You're right. We're missing some things. So let's take a look here. How's that look? Is that a little bit better? Yeah, we're starting to see some cloud coverage. Now, this isn't live, but this is a good representation of what it might look like if we were looking at our planet from space. Now, a nickname that we've given our planet, if you're looking at it from the space view that we're giving it right now, is the blue marble. Have you seen that? Do you see how it kind of looks like a blue marble? Now, why is Earth so important? Why is Earth so important? Well, for starters, Earth is home, right? Not just for us, but for all the animals that you have come to love while exploring the Aquarium of the Pacific's online academy. Now, let's take a look. If we were to circle around Earth, wow, check that out. We're going to talk about that in a little bit. If you were flying around Earth in a spaceship and this is what you see, is that accurate or are we missing something else? Yeah, it's not going to be daytime everywhere. So we can actually put half the Earth in darkness, right? The sun is over there and the entire half of the Earth is in darkness. So right now it's like kind of sunsetty on the East Coast. Okay. And then we're moving through and now it's getting sunsetty on the West Coast. Now the Pacific Ocean is in light. So this is just an example of all of the things that go on planet Earth at any given time. There's a lot happening, right? There's clouds, there's daytime, nighttime, there's movement of the Earth around its axis, there's movement of the Earth around the sun. And again, we spend a lot of time talking about coral reefs and kelp forests. How is all of it connected? Okay. Let's go ahead and explore something else. I'm going to pull up something called a data set. Okay. Now a data set, you'll see I'll pull up a list over here, is where scientists collect data, okay, collect information, and we actually turned it into an image. Now what I'm going to do is I'm going to pull up our blue buoy and float locations. It's going to take a second. Take a look here. All of these dots you see, especially right along the coastal edges, all throughout the Pacific Ocean, these are all buoy locations. Now, if you look down on the far right of your screen, you'll see there are, or left, you'll see there are buoy types, right? And so different colors represent different things. But all of these buoys that you see floating in our oceans are collecting information. And that's one way that we can study our planet. Because remember, over half of our planet is oceans. And if we're collecting information from the ocean, we're learning a lot. Now, I want to pause for a moment. What kind of information might we collect from these buoys? What kind of information might we collect from the ocean? I'm going to take a moment, see if anyone wants to chime in. What kind of information might we collect from the ocean? Go ahead, text your thoughts into 562-286-1838. Someone chimed in. They said, what about temperature? Yeah, great job. That's a huge one that we look at. Temperature. We're going to talk about that here in a minute. Ooh, someone else said what kind of animals we might be getting. or we might see. I like that thought. What kind of animals might be in any given area? Some others that we might collect information on are the movement of water, how fast a current is, right? We might also be collecting information on the salt in the ocean. How salty is it, right? Or how acidic is it? Have you ever heard of an acid? Now, the ocean water is not going to burn you, but there is an acidity or a basicness, meaning it's the opposite of acid. And we can study that throughout the globe. So based on all of these buoys and all sorts of scientific experiments done by people all around the Earth, we can gather a lot of information about our planet. And we don't even have to be in a spaceship looking at it from above. So let's go ahead and check out something else. We're going to look at some of the information that came from all of these buoys. And we're going to look at one of my favorites, which is right over here. Now I want to give you all a moment to take a look. What do you see on the screen? Let's rotate a little bit. What do you see on the screen? Are we still looking at the same planet? Because I don't know, but that looks very, very different to me. But this shape that's coming up right now is very familiar. In fact, I think that's Florida. Right? And if that's Florida, that must mean that I am hanging out right here. And so the shape of the land and the color of the land is still telling me that we're looking at planet Earth. Right? But how does this differ from the last image of Earth? The ocean looks very, very different, right? Very different. So what are you noticing? What colors do you see? Someone said they saw red. They saw orange. Someone says green. Yeah, I see a lot of blue in there as well, right? So the colors are a little bit different than we might expect. Now, remember at the very beginning, in just a minute ago, when I asked you what we might learn from those buoys, one of you said temperature. So this data set that's on the screen right now, remember, data set is information put into an image here, is the sea surface temperatures. So take a look down here. We actually have a scale. Okay, see that? So the blue, the darker the blue, the colder the water. So like right up here where that ice was earlier on, you can actually see it way up there, right? The white coming down. Ooh, it's spreading. That dark, dark blue is really cold. But this red and orange that we see along the middle of the planet Earth, that is really warm, okay? So we're going to go ahead and we're going to go wee all the way back over to the Pacific. We're actually going to take a look at this right here. And I'm going to pause it. I'm going to pause the rotation. I'm going to pause the screen. What do we notice? Do you see any patterns? Where do you see the dark blue? Oh, is that the dark blue? No, it's not in the center. If you take a look, there's dark blue way up at the top. There's dark blue way down at the bottom. And that's because our poles are typically colder. But right around the center here, whoosh, straight across, we actually have a band of incredibly warm water, right? Incredibly warm water. And so we're going to press play again. We're going to see what happens to that warm water. You'll notice it's all moving that way. See this current here? Remember one of the other things we collect from those buoys are currents, the movement of water. So we can actually see the warm water come across. Ooh, it started over. Warm water's coming across. Got real warm water. Holy moly, look at that. To give you point of reference, the Great Barrier Reef is right underneath my finger. Comes across. And look, it starts to mix. Do you see how it's kind of going upwards a little bit? Mixing up and coming up and around. Ooh, look at that. Look at that current mixing right in there. Now, as the water moves towards the poles, it actually starts to cool down. And we're going to go back all the way across the Pacific, whee, to the California coast. So So once again, I'm coming to you right there. Okay. And the water went across, it came up, it cooled, and you'll notice that the blue starts to come down along the coastline, right? Now, once again, if you've been paying attention to our programming, and if you've been learning with us over the last year and a half, or even just the last week, you will have discovered that we talk about coral reefs and kelp forests. And when we talk about coral reefs, we're usually talking about coral reefs in the tropics, in this warm water band. And when we talk about kelp forests, we often talk about kelp right here off the coast of California. And that is because corals like warm water, like we can see on the screen here, and kelp likes cool water found off the coast. So what we're going to do is we're going to jump into two of those exhibits. Let's go ahead and start. We'll start in our Shark Lagoon tropical reef. We're going to go real warm water for a moment. So what we're doing is we're going to hang out in that red band right along the center, okay? And we're going to go ahead and explore what kind of things we notice. So I already said we're going to a coral reef, but I want you to think more about that globe we were just looking at and how it connects to our coral reef. What do we see here? So if we're in warm water, what things might you see in this screen that would help support that idea? Or what things do you see in this screen that you might now discover like warm water? Is there anything on this screen that surprises you? I see a lot going on. I see a lot of sharks swimming around. Like I said, this is our Shark Lagoon. In the back there, do you see it? That is our turtle. Disappeared behind all these sharks, of course. But we have turtles in coral reef habitats. Turtles are often thought of as a very warm water species. We have a lot of sharks, which sharks are global, but there's a lot of different reef sharks seen in coral reefs. You'll see there's a lot of colors in this screen. Do you notice that? Especially in the front here where it's all lit up. I see greens and reds and oranges and yellows. So once again, my friends, feel free to share your thoughts, share your ideas at this phone number right here, 562-286-1838. Once again, 562-286-1838. All right. So colors, warm water. Now this is just one example of something within that band, okay? Let's go ahead and now we're going to jump to a colder water habitat. We're going to jump to the coastal California area of the Kelp Forest. Now, I love jumping over here because at first thought it's like, oh yeah, it's kind of colorful. But then you realize that's just the light filtering through, right? We've got some orange fish. Orange. We got a real bright orange one down here. We got some green algae growing, right? Maybe some brown algae. But for the most part, we're seeing grays, blues, and greens. We don't have those beautiful, bright colors that we might associate with the warm tropics. Now, here's the thing. This green algae that you see growing here, it likes cold water, okay? Loves cold water. There's a lot of nutrients, a lot of food in cold water. It likes the temperature of being in cold water. It likes the light and it grows up nice and healthy in cold water. So the two habitats that we just explored were examples of what the habitats look like when they're happy with the temperature of the ocean. All right. Now we're going to jump back to that screen. We're going to jump back to the Earth, I should say. And we're going to discuss what might happen if any of those currents change and if the sea temperature changes. Okay. So let's go ahead and explore our Earth one more time. All right. So check it out. Remember, coral reefs, like we just explored with our sharks, are very happy in this band. Whee! Very happy. And kelp forests are found along the California coastline here. They're also found in about 5 other places. One of them is right down here, the southern edge of Australia. And that can surprise people because when we think of Australia, we think of coral reefs, right? The Great Barrier Reef. Take a look here. Do you notice the color difference depending on where in Australia you are? Let's go ahead and just watch the temperature in Australia play through. There we go. Watch what happens. It'll take a moment to clarify. Ah, there we go. So you'll see some of that red comes over. It mixes with the yellow. It's a nice, happy, warm temperature. Ooh, it cooled down a little bit. Look at that green come in. Now, this is in January, so you'll see it actually cools down. But what's going on down here? All this blue is coming up into the coast, and it's actually starting to look very similar to the water that we see off of California. Ooh, and now as we get more towards, oh, let's see, we're back in January. Ooh, we're going to keep going, getting into February. March, April, May. It's starting to warm up a little bit. You can see this red coming in, right? So oceans are always mixing, and that's okay. Slight fluctuations in temperature, that's normal. Those oceans are able to handle it. The animals in the oceans are able to handle it. But what I want to talk about, I want you to invert these colors. I want to see if I can do that. I don't know if I can. I don't think I can either. Whoa. Whoa. I flattened it. All right, so we're not going to be able to, but I want you to do so. I want you to switch them. What would happen if this was red? What would happen if this was red and this was blue? I want you to think. Tell me a little bit about what the Earth would look like if that was red and the center was blue. What do you think? What's going on there? And so instead you had blue mixing with green and then yellow and then red. Right? Where do you think we would find coral reefs? Well, we'd find coral reefs at the poles if we were switching the colors of the ocean temperatures. And you would find kelp forests in the equator. Wow! What a different world that would be. But that's not going to happen because animals can't adapt that quickly. Now, I want to talk about that word for a second. Adaptation. I'm going to put that big word on the screen for you. An adaptation. Okay? Have you ever heard that word before? Adaptation. Well, my friends, an adaptation is something that an animal has on or in their body that helps them survive. It looks like we're getting some thoughts coming in. So we have some questions coming in. We'll get to those in just a moment. We're going to finish our adaptation talk here. So adaptation is something that animals have on or in their body that helps them survive in their habitat. So remember, I mentioned that corals like warm water. They love this band right here. Now, if it gets too cold or even too hot, corals can't just get up and walk to where the water should be, right? Corals actually don't do very well in changing temperatures. And so if we were to just drastically switch the temperatures in the oceans, corals would actually die off. They wouldn't be able to survive because they have adaptations that help them survive in warm water. Now, the same goes for the kelp forests, right? Just off the southern part of Australia, just off the west coast of the United States, off of California, Washington. And so if we were to do that, kelp, remember our kelp growing? Kelp really likes to grow in cold water, high nutrient areas, okay? What if all of a sudden, boom, that area was warm, hot water? Our kelp's not going to be able to adapt to that, right? They're not going to be able to change and survive fast enough. And it's actually, that's a very extreme example, right? If we were to just press a switch and watch those temperatures change. But it is an extreme example of what's actually happening today. We're starting to see warmer water spreading out from the equator. We're starting to see cooler water in areas that we don't expect it. And we're experiencing something called climate change. Now, you might be standing there going, well, Dana, we've been talking about the ocean, and all of a sudden you jumped to climate. Why is that? Well, my friends, it's actually this movement of temperatures around our Earth's oceans that helps control our climate. Just like our heart pumps nutrients and temperature and heat all around our body, the ocean is the heart of planet Earth. It's moving nutrients and it's moving heat around the globe. And so that affects our climate, right? Affects what's going on all around. And so again, climate change is also a change in ocean currents and ocean temperature. Now, let's go ahead and jump to this question we have here. We had someone asking, we have green algae off the California coast. Yes, we do. We have a lot of different green algae and brown algae and red algae. What happens off the coast of Indonesia? Let's go ahead and look at the temperature off the coast of Indonesia. I'm actually just going to stay zoomed out and look at this whole... Ooh, let me stop the... All right, so look at our coastline. Right? Blues, greens, every now and then we even get some of this dark blue coming in. So the algae that we have off of our coast thrives on this cool, nutrient-rich water. I'm going to zoom out and mostly just look at this whole region. What do you see going on over here? Do you see any of that blue? Do you see any of that dark coloration coming through? Yeah, so this is all much warmer water. So there are algae that can grow in warm water, but it's not going to be the same algae that we have here in California. However, that being said, there are, because of climate change and because of the change of temperatures in our oceans, we are seeing some algae that we wouldn't expect to find off cold California. We're actually seeing these algae come in and thrive. There's a species called sargassum. That is an invasive species of algae that is coming over, and it likes slightly warmer water than our giant kelp. And so giant kelp likes this real cold water, and it's like, yes, I can grow. I'm so happy. Then the water gets a little hot, a little bit warmer. And giant kelp is kind of like, I don't like this as much. But the sargassum is like, hey, I like this a lot. I'm going to spread out. I'm going to get nice and comfortable, right? And so it's actually competing with our giant kelp. Now, that's just one example of how algae might be found in areas that we're not expecting them. Now, we do have another question coming in. Someone wanted to know, do sharks have adaptations? And I love that because it kind of brings up 2 points. Yes, sharks are very well adapted to their habitat. But the next question is, what exactly is a shark's habitat? Because we were looking at sharks in coral reefs, right? Which is this very warm area. And yet we also have sharks up in the blue, up in the green. And so sharks are adapted to live all over planet Earth, all over our oceans, I should say. Sharks haven't quite figured out how to live in like Kansas yet, but they're working on it, I'm sure. And so sharks are adapted to live in all of our world's oceans. Now, there are a lot of sharks in the coral reef habitats, right? There's a lot of sharks that typically live in our warm water, but there are some shark species that migrate, like our great white shark will actually can find itself in all sorts of temperatures, usually colder, but they can travel across oceans. Sharks' adaptations are their fins that help them swim, right? Their dorsal fin on top actually helps with stabilization, as do these fins here. Their tail, right, helps them move really, really strong through the earth or through the waters. They have gills to help them breathe. So yes, sharks have adaptations, but it's not necessarily temperature dependent adaptations, okay? That was a wonderful question. However, it also leads me into another thought. Carrie, let's go ahead and see if we can go back to Shark Lagoon for a moment. See if our sea turtle friend is still swimming around. Now, sea turtles, I mentioned, are often thought of as a very warm water species, right? And yet, we do have sea turtles right here off the coast of California. We have some sea turtles that live in the San Gabriel River. We have a handful that live down in San Diego. We have some green turtles that are spotted quite often. And so turtles, there we go. Hey, big guy. That's our little olive Ridley sea turtle. Now, sea turtles are temperature dependent animals. Their adaptations actually help them survive in certain ranges of temperatures. In fact, sea turtles nest in the tropics. So sea turtles are nesting in very warm water. They haul themselves up on their beaches, right? All the way up on the beach, and they lay a nest on the beach. So those sea turtles go back to the same beach where they were born. And they're all born in that nice warm water band. Now, sea turtles are reptiles, okay? that means they are cold-blooded animals. Now, that doesn't mean the blood running through their body is cold. It just means that their body temperature changes based on the environment. So sea turtles who are usually in that nice warm water, their body likes that. Their body can move around, right? Now, when sea turtles find themselves outside of that comfortable temperature range where they're too cold on either side, we actually see sea turtles get something called cold stunned. I want you to think for yourself, right? When you play sports or when you go outside or when you're really active, do you warm up first, right? Do some jumping jacks, get ready to go. Whew. Yeah, that's because your body moves better when you've warmed it up, right? Now, you know when it's really, really cold out and you feel kind of stiff and you're like a little bit uncomfortable? Yeah, well, you and we are actually adapted to kind of deal with that. Sea turtles are not. So when they get really cold, they start to struggle and they actually can't move as fast and their body gets stunned. And so with climate change, we're seeing these dramatic storms start. We're seeing this cold areas and warm areas where we don't expect them. And the animals that are dealing with it are not adapted to that change. Now, there is one sea turtle that is found in cold water, and it has a really cool adaptation. And its adaptation is called Gigantothermy, which is a really big word for saying it's so big that the cold doesn't bother it. So gigantothermy, giganto meaning big, thermy referencing temperature, right? And so the leatherback sea turtle, which is the biggest sea turtle in the world, they are so big that their body doesn't cool down when it's found in cold waters. So that is a sea turtle species that can withstand a little bit of change. Now, that was an awesome discussion about how temperature plays a part in all of the things you see on the screen here. Thank you all so much for exploring with us and discovering a little bit more about Earth and our oceans. I hope you had fun. We'll see you back for another online Aquarium Online Academy on Friday morning. I hope you all have a wonderful week. Bye-bye.